Ladies and gentlemen, good morning. It's an honor to be here today, and I thank Professor Hanan Bouifel and Professor Dina Husseini for inviting me. I'll talk today about how artificial intelligence and medical imaging perfectly match to forge a powerful and transformative synergy. And I will start with this slide. In 2012, a team of researchers from Toronto University, led by the famous Jeffrey Hinton, designed a piece of software that was able to learn visual recognition by itself from a large amount of data using deep learning algorithm. That deep learning algorithm was called AlexNet. AlexNet was submitted in the same year to the global competition of large-scale computer visual recognition, hosted online by T.C. Lee from Stanford University, and it won. AlexNet beat every single computer vision algorithm that was developed by leading computer vision experts who painstakingly handcrafted algorithms specifically for visual recognition. The unprecedented level of accuracy of AlexNet caught the attention of every computer scientist around the world. And that moment would go down in history as a big bang of modern artificial intelligence. That changed the world and initiated an avalanche of research into deep learning. Now, just 3 years after this big bang, we had Google, Microsoft, and Baidu of China achieve superhuman visual and voice recognition capabilities. Something dramatic has happened. For the very first time, computers writing software by themselves, that software writing software, have been able to achieve superhuman levels of the two most important sensory inputs that are the foundation of human intelligence, sight and sound. Just keep that in mind. For the very first time, software writing software. Now, to set the scene for my talk, I will briefly look at the evolution of both imaging and artificial intelligence. Now, imaging came to the scene in 1895 with the discovery of X-rays. However, for about 50, 60 years, nothing much has been happening. We were stuck with 2D imaging, which were analog. However, with the advent of microprocessors and microcomputers, we started seeing multi-sectional imaging, and with that, an abundance of data came to the scene, leveraged and driven by healthcare demands, and that led to a widening gap between supply and demand. Now, there was a lot of demand for radiological investigation, but there was a limited supply of radiologists and technologists, and that meant there was this huge gap between the workload and the radiologists and technologists having to deal with that workload. And what that meant is increased workload, workforce shortages, and decreased reimbursement for procedures. And that translated into backlogs, high error rates actually approaching 30% in some areas, and burnout of all staff involved. Now, how do we deal with that? We knew it wasn't humanly possible, and we started looking at other ways. AI was one of them, and in fact, by the 2010s, we really started to see AI as a potential solution to challenges faced by us radiologists. Now, let's define AI. What is AI? AI is basically referred to computers capable of emulating human intelligence. What are the hallmarks of human intelligence? The ability to solve problems through learning and reasoning. Now, by the mid-20s, after that Big Bang, we became aware that AI is really changing our lives. You look at face recognition when you wake up in the morning and reach for your phone and put it unlock unless it sees you, social media, voice recognition, aviation support, Google Maps search, banking security, Netflix, and these are all applications we use on daily basis, and they're all governed by AI. And if it were not for AI, all these applications would really crumble. Now, let's look at AI. AI was conceived in the 1950s by this man, Alan Turing, but they remained rule-based till the 70s. However, with the advent of microcomputers again, we were able to see the utilization of massive data, the introduction of machine learning and deep learning models, as well as the introduction of new computer processors, namely the GPUs, that were able to handle these data, this amount of data, to produce problem-solving abilities. And what really made it even more present was the introduction of ChatGPT, which for the very first time gave man the ability to interact knowingly and directly with artificial intelligence. And that was, again, a moment of change that made the public aware of the value of AI more than any time before. Now, let's change the scene and let me show you some clinical images of how AI can help us. And I'll take you on a very quick tour of what's happening in our facilities. Of course, for most of us, for most people, AI is the ability to read images, X-rays, such like this, and it does, and it's pretty good at it. In fact, it's even better than radiologists. I'm sorry to say, Dr. Dina, but it actually beats us when it comes to reading images. But reading images is only one aspect of AI in the radiology department. Before we even read images, AI looks at images and corrects for artifacts such as these because the radiation dose was very low, and it gives us images that we can diagnose from. It allows us to reduce the time of scanning. So if you reduce the time of scanning, you get lousy images such as this. However, with AI algorithms, you can correct for all that noise, and you have proper images. What about contrast medium? Everyone fears contrast medium, not least the radiologists. Now we can actually cut the doses of contrast medium by up to 90%. So you're only giving your patient 10% of the recommended dose of contrast, and you're saving yourself a lot of money, you're saving your patient a lot of inconvenience, only because AI can selectively boost that contrast medium. How about creating images out of nothing at all? So this is an MRI image, and through transformative AI technology, we can actually change it to CT images without that patient being irradiated. Sounds like magic, but it's reality. How about doing angiography without using a catheter? This is CT angiography, but not only does it show us the arteries, but it actually quantifies the amount of blood flow in these arteries, and it shows us the obstructing elements, the plaques, in detail that was until now unheard of. Emergency, and Dr. Mariam mentioned that while the patient is on the table, AI can detect that we're having an emergency, this is an infarction, and automatically sends an alert to the system and actually informs the doctors in charge that we have a patient that's still on the table being scanned that has an emergency that needs to be taken care of. Automated reporting. Every radiologist free. Now we have systems that can actually extract the findings, put together your impression, and actually generate a report for your patient to understand in layman terms, all automatically. That's a dream come true. Now let's come to the last part of my presentation where we're going to reflect on that relation between us, the radiologists, and artificial intelligence, other things that might be interesting for Medina, for everyone around. Now, Garry Kasparov, a famous chess player, world champion, said after losing to AI in 1997 that the best predictor of winning human-AI pair is not the player expertise nor AI sophistication, but the strength of the strategy for working together. And these are the terms of engagement for us with AI. It's that add value relationship. Right now, we are in the honeymoon phase of our relationship with AI, simply because we need AI to support us with our workload, and AI actually is coming to the market in droves. We have over 1,000 applications that are FDA approved, 750 of which are radiology. So there is a lot to play with. This is the honeymoon phase. But honeymoon doesn't last very long. And if you thought that flirting was only a human trait, no, AI actually flirts. So we see AI actually seeking relationships with non-radiologists, with cardiologists, with neurologists, with emergency physicians. So that's serious. And what that sells is the possibility of radiologists being abandoned if AI is total autonomy. That's the fear. However, you should know that maybe we're not really ready to be totally abolished. So radiologists, I do not think, are ready to be thrown into oblivion right now. So, in closing, my perspective, and a lot of people like me, we believe both radiologists and AI will evolve together, giving rise to a new form of intelligence where the whole is greater than the sum of the parts. And that in itself will be good justification for sustainability of the relationship. And this will force the relationship, paving the way for AI to become an integral part of imaging workflow, and it will secure the role of radiologists, most importantly, to exercise control and oversight in the imaging workflow. What that ultimately means is that patient care will be improved. With that, I come to the end of my presentation, and I thank you for your attention, and I will leave you with that slide. If you want to take a photograph of these are some resources that you might find useful, if that's something is interesting. Thank you very much.